Check out this service call. I'm going over there to work on a barred unit. Let's see what's wrong. Woo! There it is. Doors open. It must be hot in there. Probably an electrical room. Got it on cooling. Feels like the fan's not running. 60 degrees in here. All right. Set up a ladder, take some panels off. Okay, so got it all opened up. We want to make sure there's some refrigerant, so we put our gauges on. We want to make sure there's power, so check with the meter, or you know what I like to do? Just push the contactor in. No power, no light on the little phase monitor there, so we need to check the breaker. It's 3-phase. We got 3 legs of power coming in, so let's find the breaker. Okay, so it says it should be a 30 amp breaker depending on the model, and it's 460 volt. Wow. So where are the breakers? Oh, probably right here. Ah, there's a 40 that's off and another 40, but those aren't 3-phase, so this is not it. Let's check around. Down here, HVAC, MCC Room. Okay, so we're going to flip that off. We're going to open up this panel, check, see if there's fuses. All right, so this one right here goes to a transformer, and I had to actually take this bar right here. This is a safety, and I had to push this up and then push this up. That way it would let the switch turn on and keep power to the transformer, because look, it turns a lot of things off in here, like the lights, like that fan, and I need to have this on, but you can't pull this up, see, unless you take this bar and then you whoop. All right, so we got a, looks like a breaker here. All right, so this one is off, this one is on. You got to flip this switch up for that to be on. You can't do it unless you hold this safety bar up. Now that we've got it on, let's check voltage across. All right, power comes in on the top. So we're going to check from L1 to L2 and then L3. Got 425 volts. I'm going to check the bottom. That was L1 and L2. We're going to check T1 and T2. 425. I bet you we got voltage, but what we also got is we got a contactor, and that contactor has a 120 volt coil, and I bet you that's what provides power to that HVAC unit. But I wonder what the coil of that contactor, what controls that coil. So let's find out. Okay, so there's a white wire and a red wire, and you can barely see it, but I checked the voltage to the coil, and of course we don't have 120 volts, and I traced those wires, and they go down here, then they go through here, and then they go up in here all the way up right here. And before I could take this panel off, I noticed something. Trip breaker. And it says for PLC power. Yeah, that's number 1. So I'm just curious. Well, nothing happened. Guess I got to keep taking panels off. All right, so we're going from that panel up, over, and then you can barely see it. It goes up into that conduit that's in the middle. It comes down and it goes into this PLC. So you got these flathead screws that I've already loosened up. Okay, there it is, the white and red wire. Now, the problem is in here, and I gotta find it. I have traced the wire down to this breaker right here, 20 amp breaker. Contactor's pulled in now. Fan's running. Outdoor fan's not running, but the indoor is. Woo! Man, that was a wild goose chase. Cause and effect. We have a reason why that breaker tripped, and now we're waiting for the outdoor fan and the compressor to come on, and we're gonna find out why that breaker tripped. So, let's go. Fan is not turning. I don't recommend what I'm about to do. Okay, so that's what's happening. It's the fan's getting locked up. Let's check the capacitor, check the bearings on the fan, and our compressor is running. So discharge line's hot, suction line's cold, but our outdoor fan is likely the issue. So we got a capacitor right here. Is that bulged? I don't know. We'll check it out. All right, I'm gonna go ahead and turn the breaker off. Okay. Close this door so you guys can actually hear because it's so loud in there. I'm gonna take out the 4 bolts that are holding the bracket that holds this outdoor fan so I can actually check the bearings because it's hard to get my hand in there. And it's a 7/16 socket, just in case you were curious. I'm gonna take these 4 bolts out and I'll take the wiring loose, get this fan out of here. It's likely the bearings are bad because I did check the capacitor. If you don't know how to check a capacitor, just check out my playlist, HVAC Tips for Technicians. I have a video. The outdoor fan motor is not 3-phase, it is single phase. We got a yellow, a black, and a brown wire. If you're curious where those were connected, we had a brown to this side of the capacitor, the yellow to this side of the capacitor, and this yellow goes to one side of the leg. And then the black wire went to this terminal, and this black wire right here connects to another side of the leg, okay? So it looks like it goes down though, and I think it breaks the pressure switch, which is a little unusual. What? Okay, so I've got an easier way to get this whole entire assembly out. I tried loosening these bolts, but there's a nut on the other side, so I kind of have to get something in there on the other side to hold it. So what you do is you just take the screws that hold this bracket in place. There's a couple screws here, a couple screws here, same on the other side. And once you do that, you should be able to slide this out. Okay? So that's what I'm gonna do. Or you could just take this out of the way so you can get to those bolts. See that? Not the bolts, sorry, the nuts. See the nuts? The nuts is right there, okay? But I'm just gonna take this whole entire thing out. Now this right here, this railing almost made it to where I didn't have enough clearance to get this out. But now I can check the bearings. Well, almost, never mind, hold on. Well, the bearings do not feel bad. This is a 460 volt motor, so I do not have anything like this. It is single phase, you can see phase 1. So I will have to order this motor. Wonder how hard that's gonna be. But you need to verify power, make sure you have power. So I'm gonna show you how I verified there was power, and I wanna talk about the pressure switch and how it's wired. So T2 and T3 is the power that goes to this outdoor fan motor. And you can see there's a black wire that comes from T2 terminal. See that right there? It's got that white spade. So we've got another black wire that has another spade, and our fan wire actually connects to this terminal, right? So the pressure switch is sent power from T2. It goes down, it goes into the pressure switch, and then it comes back out, and that's what powers that fan. So if the pressure switch is not closing, then it can keep that fan from having the power that it needs. Now, I verified power, so I actually checked from this terminal to T3, and my pressure switch is closed. So we got power, but I wanted you to know that, because if you don't know that, then you're gonna change a motor for nothing, and your motor might not be bad. It might be the pressure switch, okay? And pressure switches go bad. So what would I do if the pressure switch was bad? I would turn the breaker off, I would cut the wire here, or I would just take it and I would connect my fan wire directly to T2. That would be the smarter thing to do. Connect the black wire to T2. That way when the contactor pulls in, you're not going through the pressure switch anymore. As long as you monitor pressures, make sure they're not high, then you can go ahead and have this unit working, and that will buy you some time and give the customer some cooling until you can get a new pressure switch, okay? But you gotta make sure there's not a high pressure situation, right? So we got our fan motor. We're gonna take it to the shop, put a new fan motor on. Actually, I'm sorry, I'm gonna order a fan motor because I do not have anything like this. So I need to get the model serial number and order a 460 volt single phase fan. Here is the model and serial number of this equipment. So I will utilize this to get the new motor. Or if I got a part number on the motor, I can use that. This place is pretty cool. A lot of ponds, a lot of sand. A lot of off-roading. Nice pile of rocks. If you've ever done work at a sand company, if you have a two-wheel drive service vehicle, a van, truck, be careful where you go because you may get stuck. I have been stuck out here several times because I ended up sinking a little bit because I got in some sand and there was some water there, and you know what happens when you do that, when you sink. Just a little advice. Hope you're healthy, hope you're happy. I'm gonna get this fan, we're gonna get this Bard unit back up and running. Back on site, got the new motor, Bard Manufacturing, 825 RPM, 460 volt, 1/3 horsepower, single phase condenser fan motor. I'm gonna go ahead and put it in the housing here, the bracket, and then we'll put it in the Bard unit and see what we got. Blade came right off the shaft with a little bit of a twist with the crescent wrench and some PB blaster. So now I am going to take, using my 1/2-inch socket and my drill. Oh, need to put it into low speed and then hold this nut right here. You see any difference between these two motors? I do. I see a lot of difference. I see the fact that this is like an open type motor because of the fact that it's got all these vents to let air in here, but the new motor they sent me is closed type motor, which most condenser fan motors are supposed to be closed type motors, and most evaporator fan motors, they are, or indoor motors, are open type. But this is very unusual. So before I install the new motor, I'm just going to measure the resistance between the black wire and the yellow wire for the old motor and then for the new motor, and just see if there's any difference. So I got the meter set to ohms. Oops. Measuring the yellow and the black, 51. That's for the old motor. Now I'm going to measure the new motor. All right, checking the resistance between the black and the yellow on the new motor. 58. So there is a little bit of a resistance difference between the two motors and the yellow and the black wire. Interesting. Excited to see what happens when I put this motor in. And as you can see, the yellow was common, the black was high, and that's what we were measuring. All right, we just measured the resistance of the windings. Now let's put the new motor in. Look at the old shaft, get a tape measure, and put it on the new shaft where the blade is supposed to go. That way you know exactly where to tighten down that hub and that set screw. Okay, and make a mark. That way it's exactly where the blade was on the other motor. Now, ready to put this in, let's go. New motor is installed. Got a couple wire ties so that I could hold the wires tight and away from that blade. Now we're ready to turn on the breaker as soon as we wire it up. We got a yellow wire, and this one connects to the wire on the capacitor that goes to terminal T3. We've got our black wire that connects to the terminal that connects to T2, and then this brown wire that goes to the other side of the capacitor. Moment of truth, got the gauges hooked up because I want to measure the pressures, make sure the head pressure's not too high. But moment of truth here, you can see how it's wired. Did I make a wrong decision by changing that motor? Is that high pressure switch the problem? Is the motor bad? Let's see. Indoor fan kicked on first. Need to check thermostat, make sure it's set. It should be. I'm gonna go check it. It's a little loud in here, so. Cooling. All right. So, heard a click, contactor's buzzing. Outdoor fan is working. Compressor is working. Looks like we made the right decision. I'll measure the amp draw on the motor, check the pressures, and awesome. Check the temperature split as well. Amp draw on that motor is about 1 amp, and that's what it's rated for, so we're in the clear there. Let's check the pressures. It's 410A, low side pressure is 111, high side pressure is 361. That looks pretty good. This is the return, this is the supply, and we've got our dual induct psychrometer measuring supply air temp. It's 41 degrees. It's 66 in here, so that's a great temperature split. 46 would be 20 degrees, so we got like a 25-degree temperature split. That's awesome. Now I'm gonna turn this thermostat back up. That way it doesn't freeze up overnight. About 70, that'll do. Suction line temperature is 46 degrees. Superheating is 9. Man, everything looks great so far. I'm gonna button it back up. I hope you enjoyed today's video. I hope you learned something. Let me know if you did learn something, what it is that you learned down in the comments. If you've got questions, put those in the comments because questions can become content. If you need help learning more about charging using superheating and subcooling, if you need help learning more about troubleshooting low voltage shorts, or you need help learning more about different types of motors, I've got several videos on my playlist, HVAC Tips for Technicians. Hit the like button, subscribe, and smash that bell, ding, so you know what I'm doing. If you need help, you need tech support, you need to speak with me, there's phone number access through my level 4 membership. Go check out my membership levels and think about joining. I've got an email that I can give you, and I've got several troubleshooting guides. I've got videos on ductwork, sales training, geothermal training. They're only for level 3 members, so definitely check out my membership levels. This was a good learning experience. It took me a little while to find out where the wire was going and found out that the PLC was involved in controlling this HVAC system via that contactor. So that was exciting. It was a little hard to hear in there, I'm sure, because of all the noise. But if you ever have the opportunity to work on an MCC room that has a barred unit that is for the conditioning of that room, then maybe this video will help you to have a head start. Thank you so much to my subscribers, my viewers, especially my members. You make these videos worthwhile. You make me want to do more videos. So thank you so much. Please hit the like button before you leave. And if you haven't subscribed, then smash that button and also that bell, ding, so you know what I'm doing. You've been watching HVAC Tips for Technicians. I'm Tad, and I'll keep you cool if you let me.